Hello dear students, you are welcome to RK Institute. I am Dr. RK Seni, and today I am going to discuss 10 more questions about chemical kinetics. As you know, I keep posting 10 important questions on a topic from my channel, and I think these questions help to you to improve your chemistry or to understand the basic concept of chemistry. To continuing this program, I posting 10 another questions, particularly chemical kinetics. And these questions are of different examinations like as IIT-JEE, NEET, etc. or another medical and production. In chemical kinetics, as you know, in chemical kinetics, we study rate of reaction, different type of rates like as initial rate, average rate, instantaneous rate, order of reaction, how can find order of reaction, molecularity of reaction, integrated rate law equation, and related problems. And also study effect of the rate of reactions like as concentration, temperature, etc. and the rate constant affected by the temperature, particularly in Arrhenius equation. First question number first. The concentration of R decrease with function of time in following data. Okay. For such type questions, we use integrated rate law method or hit and trial method in which we find value of rate constant from given data by the use of any integrated rate law equation. If rate constant is equal for all data, then confirm the order of reaction, and if not equal, then we use another integrated rate law equation. For example, in this question, we use integrated rate law equation of zero order. For example, zero order, Kt equals to A naught minus At, and putting the value and find K. For example, for first data, K1, the given time is 0.05 minutes. Initial concentration is 1. Initial concentration given 1. And at this time, the concentration is 0.75. Therefore, K1 equals to 0.25 divided by 0.05, or we can say 5 from first data. Now, we put another time and another concentration and find also K2 into time 0.12 minute, initial concentration same, and at this time the concentration become 0.4, therefore 0.6 upon 0.12, and K rate constant is also 5. It means the rate constant is same given data, and hence the zero order reaction. Suppose the rate constant is not equal for given value, then we use another integrated rate equation like as first, second, and third, and so on. Therefore, this method is also known as hit and trial. Therefore, order 0, because we use zero order integrated rate equation and find K with the help of given data. Another question next. Question next. Second question. First order reaction. So incorrect statement. Pehla, the concentration of reactant decrease exponentially with time. We know that the relation of concentration at time t is following for first order. At equals to A naught E exponent ki power minus Kt. And when we plot a graph between At, concentration at time t, and t, then we know exponential graph is there. It means the concentration of A decrease with time exponentially, or we know that the infinite time taken for their completion of the reaction. Therefore, after long time, the concentration of reactant become parallel to the time, and hence first option is correct. Half-life of the reaction decrease with increase the temperature. Check the second statement. We know that half-life of first order reaction is constant and depend upon the rate constant, and we know that the rate constant depends upon the temperature. First order half-life of first order reaction is ln2 divided by K, rate constant, and we know that rate constant increase on increasing the temperature. When we increase temperature, then increase rate constant and then decrease half-life. Therefore, the statement second is also correct. Half-life of the reaction decreases with increasing the temperature is correct option, because When we raise the temperature, then increase rate constant, and when increase rate constant, then decrease half-life, because rate constant and half-life are inversely proportional to each other. Say third option, half-life of reaction depends. Half-life of the reaction depends upon initial concentration. Is it incorrect statement? Incorrect ही आपसे पूछा था. Therefore, your option is C, because half-life does not depends upon the concentration of reactant in case of first order. Option C, reaction proceed 99.6%. Completion is in 8 half-life duration. Check this statement. Check the statement. First, we write a relation between half-life and time of 99.6% completion. We know that first order integrated rate equation of first order reaction is Kt ln A node by AT. For 50% completion, we write integrated rate equation K 50% equals to 2.303 log initial concentration A node, and after half-life its concentration is A node by 2, or we can say Kt 50% equals to 2.303 log 2, or log 2 equals to 0.3. Equation number 1. Similarly, we write integrated rate equation for 99.6% completion of the reaction. 2.303 log. If initial concentration is A node, then after 99.6%, suppose initial concentration is 100, after 99.6% completion, the remaining concentration is 0.4. The remaining concentration is 0.4. If initial concentration is 1, the remaining concentration is 0.4 upon 100. And if initial concentration is A node, then concentration after 99.6% is 0.4 into A node upon 100, putting this value. Therefore, A node, and hence 0.4 into A node divided by 100. Therefore, the another integrated rate equation Kt 99.6 equals to 2.303 log. Solving the equation, A node cancel, 1000 upon 4, or we can say 2.303 1000 10 की power 3 into 3, then log, then minus log of 4, and log 4 equals to log 4. Log 4 की वैल्यू होती है नियरली 0.6. Therefore, this equation is 2.303 into 2.4 into 2.4. Equation number second. Then equation first divided by equation second, and we obtain equation first divided by equation second. T 50% divided by T 99.6%. Then we obtain 2.303 is also cancelled. In equation first, the remaining part is 0.3, and equation second, the remaining part is 2.4, or we can say 1 by 8. There 1 by 8. Therefore, the statement fourth is also correct. The 99.6% completion taken 8 times of half-life. 8 times of half-life. Correct option. Therefore, C is incorrect. Question number third. Question third. Rate of reaction. Rate of reaction is doubles when temperature change from 300 Kelvin to 310 Kelvin. The activation energy of such reaction will be. We know that the rate constant at different temperature by the differencing of 10 degree temperature is known as temperature coefficient, and we write integrated rate law equation at different temperature ln K2 upon K1 equals to EA upon R temperature T1 minus T2. Temperature coefficient is 2. The temperature coefficient, What do you mean by temperature coefficient? It is a ratio of the rate constant at the difference of the 10-degree temperature. Therefore, the temperature coefficient is 2. And hence we write 2.303 log of 2 equals to EA upon R की वैल्यू जूल में आप लिखेंगे 8.314 and 1 upon T1 300 and 1 upon T2 310. On solving the equation, we find activation energy 53.6 kilojoule. Solve कीजिए equation को. Then question number 4, reaction P into Q. The time taken for 75% reaction of P is twice then taken 50% of reaction P. It means with regarding to P, it is first order reaction because this time ratio is 2:1, or we can say time taken to 50% to 75% for first order reaction is 1:2. Therefore, regarding to P, equation is first order. Order of P is 1 because with the help of given half lives and their 75% completion. For the concentration of Q varies with time is shown in this graph. The concentration of Q is completely consumed, or we can say reaction is 100% takes place after a finite time, and this is the characteristic of zero order. Therefore, the order of Q is 0 and sum of the order is 1. This relation is only for zero order reaction, or we can say zero order reaction are those reactions which are 100% complete. Their full life is complete after a finite time, and other reactions take infinite time for their completion. For example, in first order, etc. Question number 5. Question 5. Elementary reaction, the rate disappearance of M increased by a factor of 8 upon doubling the concentration of M. Find order. First, we write rate 1 is directly proportional to concentration of M, order alpha. And in given question, the concentration of M increases 2 times, then disappearance rate is 8 times. The concentration of M taken 2 times, then the disappearance rate become 8 times. We solve the equations and find order. Equation 1 divided by equation 2. Therefore, 1 upon 8 equals to 1 upon 2 की power alpha, or we can say 8 equals to 2 की power alpha, or 8 equals to 2 की power 3 equals to 2 की power alpha. Then base are same, then order are also equally, exponent are equal. Therefore, it is third order reaction. Question number 6. Higher order more than 3 reactions are rare due to laws of activation energy of collision दी नहीं. The low probability of the simultaneous collision of all reacting molecule is correct option. Next, question number 7. When more than three molecules are there, then the very less probability for the collision of more than 3 molecules simultaneously. It means the order of reaction is rare greater than 3. However, some reactions may be order 4, etc. Like as when Kinetics reaction carried out in presence of highly concentrated base, then this order of reaction is 4, but rare. In dilute solution H2SO4, the complex, this iron का complex है iron 2 oxidized by MnO4 minus. For this reaction, the rate change of H plus ion to the rate change of permanganate ion. First, we write balance reaction of permanganate ion in acidic medium. In acidic medium, permanganate ion change into Mn plus 2. For balancing the oxygen, we added water molecule. For balancing the hydrogen, we added H plus ion. And for balancing the charge, we added electron. And now we check rate disappearance of H. Change to rate disappearance of M. तो यहाँ लिख देंगे अपन rate disappearance to H to the rate disappearance of permanganate ion is 8:1. The stoichiometric coefficient of H plus is 8 and the permanganate is 1, and hence D option. Question number 8. Question 8. Similarly, find value of T 1/8 or T 1/10 for first order reaction. Organic compound undergo first order reaction. बस आपको क्या करना है, फाइंड करना है टाइम रेट. तो वी राइट इंटीग्रेटेड रेट लो इक्वेशन for 1/8 time ln a node upon 1/8. It means a node upon 1/8. Equation number 1. And for second given data 1/10 equals to ln a node, and the reaction remaining concentration is 1/10. It means a node divided by 10. These two equations then solve. T half T 1/8, equation 1 divided by 2. Equation 1 divided by 2. Then we obtain T 1/8 to T 1/10 equals to ln 8 upon ln 10. Then 2.303 log 8. 8 means 2 exponent 3, or we can say 8 equals to 3, log 2 equals to 0.3. And for ln 10, 2.303 log 10 equals to 1. Therefore, the ratio is 0.9 upon 1. Then multiplied by 10. Therefore, our answer is 9. Question number 9. Same condition, initial concentration is 1.386 mole per liter of the substance, become half-life is 40 seconds and 20 seconds through first order and zero order kinetics. Find rate constant. For first order reaction, we know that rate constant with respect to half-life is ln 2 by half-life, or we can say 0.693 upon half-life, equation number 1. So given half-life of first order reaction given is 40 seconds, equation 1. For zero order reaction, K naught equals to initial concentration, the relation of half-life with initial concentration and K into half-life. Putting the value, the initial concentration given 1.386 mole per liter ये divided by K naught into half-life divided by 2 होता है, 2 into half-life given 20 second, equation number 2. Divide equation 1 to 2. Then we obtained K1 upon K naught for zero order is 0.693 upon 40 divided by 1.386, so 6 into 2 into 2 into 20, and hence we obtained, this is m, 1/2m. 1/2m means 0.5 m. Question answer A. Question 10. Therefore, we write, for such type questions, we write relation between half-life and rate constant. First order reaction, the half-life, that their rate constant does not depends with half-life is ln 2 upon k. And in case of zero order reaction, their half-life directly proportional to initial concentration, and we can write A naught equals to K naught, K equals to A naught upon 2K. Question number 10. It is the question from Arrhenius equation. We know that Arrhenius equation equals to log K equals to log of A minus EA upon RT. In given this equation, the equation given log K equals to minus 2000 1 upon T plus 6, pre-exponential factor A, and find activation energy. Compare the given equation to the Arrhenius equation. Therefore, 6 equals to log A. And hence log A equals to 6, or we can say Arrhenius parameter A equals to 10 to the power 6. 10 to the power 6 A. And similarly, this equation compare Arrhenius equation minus 2001 upon T minus 2001 upon T equals to minus EA upon RT. Check. Minus EA upon RT equals to minus 2000 into 1 upon T. T cancel to each other, and then multiplied this equation 2.303. This equation is also minus EA upon 2.303 into RT. Clear this equation 2.303 into RT. 2.303 into R. T cancel and negative sign is also cancelled, and given value multiplied by 2.303 into R. R equals to 8.31 joule. Therefore, their answer is nearly 38.3 kilojoule. Option D. And these are the some questions from chemical kinetics. In another lecture, we also posting 10 important questions regarding chemical kinetics also. Okay, bye.